Hi, my name is Saeed. I'm a Senior Technical Officer at PowerTech Wireless Technology, and I want to welcome you to our YouTube channel, your ultimate guide to the world of connectivity and technology. Today I'll talk about MIMO, which is a really popular technology and actually brought us to a higher data speed and really good connectivity. Now, to start with, I would like to just quickly catch up with SISO, which is single input and single output, which means like there will be one transmitter antenna and one receiver antenna, and it's pretty basic. Signal come out from the transmitter, transmitted out to the receiver, and receiver gets the signal. Pretty simple, one radio link and the communication established. But there are a few limitations, like if the frequencies are limited, number one, and also when it's wireless, the signal from the transmitter actually gets some sort of fading when it's out on the air, like a reflection, refraction, or time delays. There are a few. I'll go with the list. So with those limitations, that's when the MIMO came into the play. SISO was really popular with some technologies like 2G, 3G, UHF, point-to-point communication, and then also in the IoT space like LoRa, even NB-IoT. Because all those technology doesn't require much of a higher data speed, so even though with that fading we talked about, it's still okay. But for the further communication, like on 4G, 5G, MIMO is a must to have that higher capacity. So going back to that fading, I'll just quickly touch base the items what we normally look at. To start with, it's just the multi-path fading, where the signal reflects in a different components like objects, like a building or trees, even hills sometimes, which causes the multi-path fading. It actually gets worse in urban area because there is a multiple high-story building. You can imagine if the signal's coming off and there are like 10 buildings, it will be bouncing off different buildings, so like a 3-4 bounce, and the signal will gonna get distorted, so which will cause loss of data at the other end. The second problem with that multi-path fading is delay spread. So if the signal is bouncing off, there will be a bit of a delay. Now the delay is between the on the symbol. You know how we will be on the signal, there will be symbols transmitting from one end to another. Now with the bounce, the symbol may get delayed a bit and overlap with the next symbol coming up. And then that causes, when it's overlap, the receiver will not gonna get a correct information. Now there is a way we can avoid that in that communication. Is just to have a bit of a delay from symbol, so that even though it's spread it out, it will not gonna overlap. It will gonna be with a guard band, like a guard band between the symbols, and that helps out with the delay spread, although there will be a delay in the whole communication anyway. And there is a frequency selective fading as well. That comes up when the multi-path fading, it's related to multi-path fading again, because one frequency, let's say 850 and 850 megahertz got few channels it used. So one frequency of the channel may hit the reflect, and probably 10% of it got faded. The other frequency will gonna have 50%, so it's frequency selective as well. Now, the first frequency the user is hooking on would get 10% loss on his data, and then the other frequency, which is getting 50% loss, will lose the 50% of the data. So that's the frequency selective. One last one I'll share is the interfrequency interference, which is a bit related to the spread delay as well. So if there's again two different frequency, one would delay a bit, and then if they're adjacent frequencies, there is a possibility to get overlap. and that will cause again interference and hard to decode the data. Our interesting bit is with all those problems we talked about, MIMO comes into the play and take an advantage of those problems, and then it uses those fadings into its advantage and then increase the link capacity and the performance. So before MIMO, I'll touch base a quick couple of advancement on the SISO, which is because of those fadings and delays, there are a few methods being put on. One is the time diversity, and the other one is frequency diversity. So still one transmitter and one receiver. The signal will come out, and then the same signal, like same information, will be transmitted over two different time slots. So one will go first, another goes second, and the receiver would know it's been transmitted twice, and that way it will get, even though it's one transmitter, one stream of signal, there will be two different stream based on time delays. And with that, when the receiver is getting two different link from the time delays, it will be able to manage it on its end and work out the errors, and will be able to revive the more information. Now that requires a bit of a processing on the user end, and then back in, I think before 1990, the processing power of the devices wasn't that much, even though on the tower. But with the advancement on the processing speed and the advancement, this is started looking a bit to be easy to implement. And similar to that time diversity, there is a frequency diversity, which is again the same. It just uses the same data stream in two different frequencies. Still one transmitter, still one receiver, two different frequencies, same information passing on. So the receiver will receive the same information via two different frequencies, and then it will again process the signals and then revive the data, will decode the data with less errors. Apart from time diversity and the frequency diversity, which is single input, single output, space diversity is where the technology headed into the MIMO system. So space diversity is on one end, transmitter end, it will have two different antennas, and then it will throw two different stream of signal with the same information. So the same information will be thrown into two different stream. On the receiver end, it may have one receiver and one antenna or two antenna. So that's the MIMO. And then I'll talk about like what happens if it's two antennas on the other end. So the idea is to utilize separate antennas transmitting separate signals with the same information. Is to one stream is expected to go straight in or reflected on a tree maybe, and the other stream probably gonna reflect on another object where the signal will be at receiver and in a different sort of condition. And on the receiver end, it will be able to again have multiple stream of same signal, and will be able to process to achieve higher speed. One thing to consider though when implementing the MIMO is the different stream of signal we're talking about carrying the same information. Those signals needs to be correlated. They need to be separated in an easy term. And if we're talking about 2x2 MIMO, the basic and easy way to do that is to change the polarization of the antenna. You know how the electromagnetic wave, the signal has it normally goes a sine wave sort of signal, which is let's say if it's on a vertical plane. So I would have one antenna placed vertically and the other antenna on horizontal plane, which means they are 90-degree apart in polarization. So the signal will going to go vertical, one go on vertical plane and the horizontal will go the other way. So they are not correlated. In that case, we can put the antennas together. They don't need to be spaced apart, because one thing is with a separate antenna, the basic rule is the signal to have a separate signals. It needs to be separated somehow. So one of the way is to having a different correlation. But that limits us in 2x2 because we can go only vertical and horizontal, or 45 degrees plus and minus, which is look like a cross. And then if we add a third antenna for 3x3, then that's not possible because there is only 90 degrees is the limit. We cannot go like less than 90 degrees. While we're saying that the limitation on the creating different stream with the same frequency, there's another method MIMO uses, is space in a space plane, which is like it will be in the same polarization, like two Omni antennas. They are same polarized, vertical, but there will be the signal transmitted out through those antennas will be phase shift. The phase shift, I'll quickly catch up with what the phase shift means, is that when we have that signal sine wave, as we said, the peak of that sine wave, the signal, the peak, it will be there will be a bit difference on a phase, so it will be shifted a little. In that case, that also separates the two frequencies. Even though they're same frequency, there will be two different streams, and they will not gonna relate to each other. It will be separated. So that's another way MIMO uses the correlation, implements the correlation, and that's the phase shift. With the phase shift, what happens is when you have two antennas and they are phase shift, the system can actually create multiple beams directing multiple direction, like facing multiple direction. Let's say I got two Omni antennas and one antenna, another antenna with a tweak on the phase. I would be able to produce one beam shooting straight to the receiver, or shooting straight, and then another beam I can create which will be angled in a way that's on, let's say, on a 45 degrees. And the intention is the second beam I'm creating is to have a reflection and then go back. So with the two MIMO, and even that's possible on a 3 and 4 as well. So we have 3, 4 antennas, and then we can have multiple beams directing different ways to intentionally create multi-paths. And then what happens is, even though on the receiver end, the multipath will benefit the receiver to receive the forward stream, and on this end, without any change on the polarization, having 4 antennas with a phase shift, we are achieving that multi-stream communication. Now again, as I said, the processing power needs to be higher on those end, which is no problem now because of the high processor we getting on our market. So those made it possible to work with the signal phase, changing it really frequently, and then on the receiver end, it will be able to decode, and happy days. That's it for today, but I'll cover another video next where I'll be talking about increasing capacity, how even though what we have talked is diversity, which means whatever number of stream we're creating, we're still using the same information multiple times, which is limited, which limits us on a capacity base. And the next video will talk how MIMO gone to a next level where the capacity increase multiple fold, and then I'll cover a bit of a massive MIMO, which is more than 10 antennas on one side, and how things are managed, and also a bit of a beam forming. Thank you for today.